Lately, we've been solving problems that involve finding factors of numbers. Have we used factors to help us think about problems in everyday life? One example I can think of is when we were solving problems about sharing things. So like when Jaden was sharing the apples and the trail mix into those snack packs, we found it useful to think about factors to help us solve those problems. What other connections have we made? So in an earlier lesson, we found the prime factorization of 100. How did we do that? Yeah, I was thinking about that part of our strategy too. We didn't just go right to writing all the prime factors. We just started with one factor pair. So I think some of us started with 4 times 25. Why was it helpful to just start with one factor pair? Just think about one at a time. I know for me, it's really helpful if I'm jumping into a big problem that feels kind of overwhelming to just start with something that's really familiar. So when I see 100, it's really easy for me to think about 4 times 25 because I think of 4 quarters make $1. So that's something really familiar to me, and I can just make a start, and I'm already working on this problem that felt overwhelming at first. So what did we do after that, though? We weren't done yet. How do we use this start to help us keep going? Maybe to write 100 as product of 3 factors instead of just 2. Yeah, that's one way. So we rewrote that 25 as 5 times 5. So we end up with 4 times 5 times 5. Yeah, and then we kept going, right? I already heard somebody say, and then our next step was we broke apart that 4 into 2 times 2. We ended up with 2 times 2 times 5 times 5. So are all these numbers in our bottom row prime? Yeah, they are. So we found the prime factorization of 100. So I want to go back to that question I asked before. Why was it useful to start with just one factor pair instead of trying to go all the way to the end? I want to talk about that some more. Talk with a partner about what you think. Why was that helpful? And then I want to hear what you're thinking about. Yeah, I'm hearing a lot of great ideas. I'm going to write them down so we can talk about them. So one thing that was helpful about starting with just the one factor pair is it helped us keep track of our work. So we didn't have to worry about all the steps at once. We just wrote down what we had done so far, and it actually really helped us see what we had done and what was still left to do. Just went a little bit at a time. And then, yeah, we didn't have to know all the factors right away either. We talked about that one a little bit already. So we didn't have to know what all the prime factors are. We just had to start. And then we were sort of going, and we could find more prime factors as we went. And then this is something I thought was really cool about starting with just one factor pair, is everyone could just start with whatever one they wanted to, whichever one felt familiar or easy to them. So I said that I liked starting with 4 times 25 because when I see 100, I just think right away, well, I know 4 quarters are $1, so I can write 4 times 25 is 100. But not everybody might think that way. So I think the first thing other people thought of maybe was 2 times 50. And they started out with that factor pair. Now, if we were to start with this factor pair, would we still get the same answer as we did when we started with 4 times 25? Let's try it out and just see. So what would our next step be? What could we do with this factor pair to write it as a product of 3 numbers instead of just 2? Yeah, we could break apart that 50, right? Maybe we write it as 5 times 10. And then, is there more to do, or are we done? How do you know? Yeah, that number 10 isn't a prime number, right? We can still write that as a product. So that means we have more to do. So we can write 10 as 5 times 2, and we end up with 2 times 5 times 2 times 5. So now we have all prime numbers at the bottom. So we have the prime factorization of 100. Is that the same prime factorization as we found with 4 times 25 as our starting point? Let's just look at them side by side to make sure. Yeah, They're the same, right? The factors ended up in a little bit of a different order, but we know that's okay because we can multiply in any order and we still get the same answer. Great. So the reason I wanted to talk about this today is that it's a great example of one of our CT practices that's called decomposition. So decomposition is breaking a complex problem into smaller parts that are easier to address. So when you come across a problem that seems big and overwhelming, like maybe you see that you're supposed to find all the factors of 100 and you're like, ooh, that seems like a lot to do. You can think about decomposition and say, what's just a piece of it I can start with? What's a piece I can break off and solve? And maybe that'll just help you get started. So we can use this strategy to help us find prime factorizations of even bigger numbers too. What number would you like to try? Does anyone have a favorite number? How about 360? So again, there's probably a lot of factors there. It's a little overwhelming to think about finding all of them at first. But we can start by just finding one factor pair. So what's one factor pair you think you can find pretty easily? Is there anything that just seems like an easy way to start? Yeah. So we know that those numbers that end in 0, we can write them as something times 10. So we could start just by saying 36 times 10. Easy. And we're not done yet. We still got work to do, but we've already got started on this problem that seemed overwhelming. We just found a little piece we could start. And not only that, but now we see as we're going on, we broke this into smaller problems because now all we have to do is find the prime factorization of 36 and find the prime factorization of 10. And those both seem pretty manageable, right? And so we just put those smaller solutions together and we get the solution to the bigger problem. So we're going to use decomposition a lot this year. When you come across a problem that seems overwhelming at first, I want you to stop and think, can I decompose this? What's a piece of it I can start with that's a smaller problem I can use to get started?